This question is from GATE 2018 Mechanical Engineering Paper Set 1, question number 17. The number of atoms per unit cell and the number of slip systems, respectively, for a face-centered cubic FCC crystal are. Let's find out the number of atoms per unit cell and the number of slip systems for a FCC crystal. So let's start by looking at the face-centered cubic crystal's structure. We know that there is an atom at every corner of the crystal. So there are 8 corners of the cube and therefore 8 atoms situated at every corner. But this single atom at the corner is shared by all the neighboring crystals as well. So for a particular unit, only 1/8 part of the atom will be present in that. And therefore we will consider, while calculating number of atoms for a unit cell in FCC structure, will be equal to 8 corners but 1/8 of each atom at every corner. Plus, there are atoms at the faces too. Therefore, it is called face-centered cubic. So, at the center of every face, there is one atom. There are 6 faces for a cube and therefore, there are 6 atoms. But for the atom on the face also, it will be shared by one of the neighboring unit and therefore, only half of this atom is present in a single unit. Therefore, we write it as half into 6. 6 faces, but half of every atom at every face. This comes out to be 1 plus 1 by 2 into 6 is 3. So, there are total 4 atoms in a unit cell of FCC crystal. Now we need to calculate the number of slip systems. So slip system basically is a combination of the slip plane and the slip directions. And these planes and directions are nothing but the plane and direction of the highest density. That is, the plane that has highest density of atoms in it will be called as the slip plane, while direction along the edge of the slip plane will give us a slip direction. So if we look at this structure, we see that if we try to pass a plane like this. So if we consider this plane that contains 3 of the corner atoms and 3 of the face atoms, and we show this in 2D, then it will look something like this. So at every corner, there is 1/8 part of the atom present, the corner atom present, and half of the face atoms are present. So that also we can show it like this. Therefore, we can see that this plane is quite dense. And in fact, it has the highest density. We are showing these atoms smaller in sizes for clarity of figures, but they are not so small in reality. Now we need to identify the slip directions. Slip directions are nothing but edges of these plane. These directions in which there is highest density of atoms constitute of the slip direction. So every plane will have 3 such directions and we will basically have 4 such planes. Or another way of understanding this is one slip direction is in one diagonal direction for a single face. So the other diagonal direction consists of other slip direction. One face has 2 slip directions. So per face there are 2 slip directions. There are 6 faces and so 12 slip directions. So number of slip systems are nothing but these directions. In total, that is 12 slip systems. So 4 are the number of atoms in FCC unit cell and 12 are the number of slip systems. Let's go back and mark the correct option. We have 4 and 12 given in option C. Option C is the correct one. To learn about slip systems in detail, you can refer to the NPTEL video, Lecture 9, Part 1, Defects in Crystalline Materials 4, Slip Systems, Berger's Vector, from the course Basics of Materials Engineering. This course is by Professor Ratnakumar Annabatulla. He is from Department of Mechanical Engineering of IIT Madras. I hope this explanation will help you clear your doubt. Thank you.